Good morning to all. I'm Dr. Janardhan Rao. Today lesson we're discussing about page replacement algorithm. In the previous session, we had discussed about what is the virtual memory concepts and what is paging and what is segmentation. So in this today's lesson, we'll discuss what is this page replacement algorithm. So what is the requirement of it. So we have seen, as we have discussed in the previous, this is your hard disk and actually your 4 GB file is here, and we want to see the 4 GB file. So this is your RAM. So RAM or main memory. So 4 GB file. See, this OS is coming here. That is the booting. So once the OS has occupied some 1 GB memory. So since it is your RAM is 2 GB, so 1 GB is left for the working place. It is working place. We are working in this 1 GB only. So we are writing a program or doing anything. There is only 1 GB available. So here the 4 GB file is there. You want to get this 4 GB file to the 1 GB file. It's not possible because only 1 GB file is here, 1 GB space is here, and 4 GB file is here. So you want to see the 4 GB movie. So it is not possible to get 4 GB to 1 GB. In that case, what we do, we go for the virtual memory concept. The virtual memory concept is we will divide this 1 GB into frames equal size 10 KB, 10 KB. This is 10 KB. And the same way we will divide this 4 GB file also into 10 KB, 10 KB. So now, since just you can see there are three slots available, 3 frames. So we will transfer 3 pages into this one. So we will maintain page table. So in this phase table, which phase has come. So frame 1, phase 1 has appeared. So this is called phase table, what we have seen in the previous classes. So here, so after seeing the 3 pages, 3 frames, so you want to see the 4th one because there are number of pages in this 4 GB. So we want to see 4th one. There is no place 4th page. So this is in the RAM. So in that case, that is we call page demanding and phase fault. Phase fault means whichever page you want to see, that page is not available in the RAM, main memory. So that is called phase fault. So we are demanding phase next page. That page is not in the RAM. So the page demanding and page fault. Whenever the phase fault occurs, automatically the page replacement algorithm will come into action by OS, and it will replace one of the frame in the RAM, and it will facilitate the next page what you demanded, that will be brought there. So automatically your phase table also will get updated. That's what page replacement algorithm will work out. So in this page replacement algorithm, it will replace one of the frame or swap out one of the page from the RAM, and it will provide the place for the new incoming page from the hard disk. So that's called page. Which page to be removed from the RAM? That is a distinction between distinction, or rather you can say that is only the value of our algorithm. Which page to be replaced? So that's what we see, the page replacement algorithm. This one, in this one, page replacement is needed in the operating system that use virtual memory using demand paging. Demand paging, only a set of pages of a process is loaded into memory. This is done so that we can have more process in memory at the same time. So when a page that is residing in virtual memory is requested by the process for execution, the operating system needs to decide which page will be replaced by this requested page, because our actual pages are available in the hard disk. So we are getting one page by page from the hard disk to our RAM. So already whatever RAM space available, that is occupied. So now we want to see another page, another page. So for another page, there is no space in the main memory. So in that case, page demanding. So when the page demanding, if that page is available in the RAM, no problem. If it is not available, that is called page fault. Whenever a page fault occurs, it automatically requests the page replacement algorithm. So that is the only thing. This process is known as page replacement. That is a vital component in the virtual memory management. So in this one, so why need the replacement algorithms? Phase fault. This is what we discussed, the phase fault, which we want to see the next page. We are demanding a page. If that page is available in the RAM, then OS will show that page to user. If that page is not available in the RAM, that's called phase fault. A phase fault occurs when a program running in CPU tries to access a page that is in the address space of the program, but the requested page is currently not loaded in the main memory or main physical memory, the RAM of the system. So that is called phase fault. Whenever the phase fault occurs, the phase replacement algorithms help the operating system in deciding which page to be removed or replaced in the main memory. So the primary objective of all the page replacement algorithms is to minimize the number of page faults. So if page faults are more, so now and then OS will go to hard disk and get the pages from there. It takes more time, so the performance will come down. So we have to minimize the page faults. So there are some page replacement algorithms are there. What is the page replacement algorithms in the operating system? First in, first out. First in, first out algorithm is the simplest of all page replacement algorithms in the FIFO. So FIFO algorithm maintain a queue of all pages that are in the main memory. So the oldest page in the memory is the front end of the queue, and the most recent pages is at the back end of the rear end of the queue. Whenever a phase fault occurs, the operating system looks at the front end of the queue to know which page, the page to be replaced by the newly requested page. So it is also adds this newly requested page at the rear end and removes the oldest page from the front end. So this is called page replacement algorithm. So just you look at this example, page replacement example. Consider the page reference strings while executing the program. It requires this many processors, or you can say this many pages for the execution, because the data is available in these pages. So we are getting these pages from the hard disk to main memory. So first initially there is just you have to assume that only 3 frames available in the RAM. Only space is available for three frames only. So initially for the execution of the program, we required phase number 3. So now 3 has been placed here. 3 has been brought from the hard disk to RAM. So 3 has been, this 3 has in the hard disk, that will be brought into the RAM. Now, okay, it's over now. So it is means initially RAM is empty, means no page available. So we are getting one page, that is first page as per requirement of the program or execution. 3 has been brought. So straight away 3 has been brought from the hard disk to RAM. So next page 1. So one again that OS will see, is there any phase 1 is available in the RAM or not? Because it is the beginning of the program execution. So there is no pages. So initially 3 has been brought. After that 1 has been brought. So this is means that's not available in the RAM, because it is the beginning. This is the beginning. Next page is 2. So for the requirement is 2. So since it is beginning, so 3 has been acquired, 1 has been brought. So now 2 has been brought. So this is also over. So now 3 places occupied, 3 frames occupied by the 3 pages. So next page you want 1. Since already 1 is existing in this one, so this is not miss. So now we can say 1 is already available, though hit. That is he called it. So next one we require 6, page number 6. So now So now OS will see in the RAM page number 6 is available or not. So 6 is not available in this because 213 occupied. So now we want to bring the 6 from the hard disk to RAM. So there is no place, already three frames occupied by the 3 pages. So now we have to vacate or replace one of the frames with some algorithm, that is first in first out. Which page has been brought from the hard disk to RAM first initially. So now that page to be replaced. So now that is your 3 is the first in the operation. So now 3 will be replaced with the 6. So like this, hit and miss will be carried out for the till the program executed in all pages. All pages have been brought into the RAM. This is the first in first out page replacement algorithm, because for the execution of the program we required one of the pages to be replaced or vacated for the new incoming page if it is not there in the RAM earlier. So that is called first in first out. This is queue. This is called queue. This is queue and first in first out queue, and this is the procedure how the program will be executing by taking the pages from the hard disk to RAM one by one. This is first in first out page replacement algorithm. First in first out page replacement algorithm, we will see similar to this first in first out. There are other page replacement algorithms are there. We will see different types of page replacement algorithms. We will see that one by one. So this is a practice you can do. So this is, we will see what is thrashing later on this one. We will see the replacement algorithms further, and there are some other page replacement algorithms out there. We will see one by one. The page replacement algorithm decides which memory page to be replaced in the RAM. The process of replacement is sometimes called swap out or write to disk. Page replacement is done when the requested page is not found in the main memory. That is called phase fault. The page replacement algorithm decides which memory page to be replaced. The process of replacement is sometimes called swap out or write to disk. The page replacement is done when the requested page is not found in the main memory. That is called phase fault. So page replacement. In this page replacement, the page replacement algorithm decides which memory page to be replaced. The process of replacement is sometimes called swap out or swap out write to disk. Page replacement is done when the requested page is not found in this main memory page fault. So virtual memory, frame allocation, how many times are to be allocated to the process, and page replacement, which page to be replaced, frame allocation and page replacement. So now, if the number of frames which are allocated to your process is not sufficient or accurate, then there can be a problem or thrashing due to this lack of frames. So most of the pages will be residing in the main memory, and therefore more page fault will occur if OS allocates more frames to the process. Then there can be internal fragmentation. If the page replacement algorithm is not optimal, then there will be the problem of thrashing. You will see what is thrashing. If the number of pages that are replaced by the requested page will be referred in the near future, then there will be more number of swap in swap outs, and therefore OS has to perform more replacements than usual, which causes performance deficiency. Therefore, the task of optimal page replacement algorithm is to choose the page which can limit the thrashing. We will see what is thrashing and different types of page replacement algorithms. So the optimal page replacement algorithm is the optimum algorithm. This algorithm replaces the page which will not be referred for a long in future. So although it cannot be practical implementable, but it can be used in a benchmark. Other algorithms are compared to this in terms of optimality. So we'll see the example also one by one. least recent used page replacement algorithm. This algorithm replaces the page which has not been referred for a long time. This algorithm is just opposite to the optimal page replacement algorithm. In this work, we look at the past instead of starting in a future. So the people already seen in this algorithm, a queue is maintained. The page which is assigned the first assigned the frame first will be replaced first. In other words, the page which resides at the rear end of the queue will be replaced on the every page fault. So we'll see examples for this one. So first in first out already we've seen. So the oldest page in the memory is the one which will be selected for replacement, for easy to implement. Keep a list, replace pages. So these are the pages required from the hard disk for the execution of the program. So this is, we see initially 0 has been brought, and next one is 2 has been brought, and next one is 1, next page 1 has been brought, because it is a initial execution of the program. So now next one is 6. So now 4 pages occupied for only 4 frames available in the RAM. So now 4 pages occupied in the RAM. So next one. So again you want to see the fourth page, fourth page from the hard disk to RAM. Since there is no place in the RAM for the fourth phase from the hard disk, you have to bring the fourth page from the hard disk. So since there is no place, it means we are demanding page number 4 from the hard disk. So there is no place for page number 4 in this RAM. So in that case, page demanding phase fault. Phase fault occurred. This is called phase fault occurred. So whenever the phase fault occurred, this is a phase fault occurred, then automatically page replacement will come into action, and it will remove the page which is used first, in the sense first enter, which is enter first 0. So now 0 is removed and 4 has been placed there. So this is called first and first. We have seen this example like this. Whatever the pages are demanding. So if the page available in the RAM, that is hit. If it is not available, then miss. So we will calculate how many misses are there in this one. So these are the total misses. They are misses by total reference strings. So now fault rate equal to total misses by fault rate. That is your total requirement of the pages. So 9 by 12. If you add all these things, 1, 2, 3, 4, 5, 9, 9 by 12. Total misses are 9. So 9 by 12. These are 12. These are 9. So 9 by 12. That is 0.75 is the fault rate. And hit and miss. If you calculate this one, this is the efficiency. You can say that one. So by using this first and first out algorithm, this is the calculation fault rate will find out. So we'll go for the another replacement algorithm. This is another replacement algorithm is optimal page replacement algorithm. So an optimal page replacement algorithm has the lowest phase fault rate of all algorithms. An optimal page replacement algorithm exists and has been called optimal or minimal. Replace the page that will not be used for the longest period of time. So for the same example, you can see these are only 4 frames available in the RAM. So we want these are the pages required for the execution of the program. So since it is a beginning, so all 4 frames, 4 pages occupied. 1, 2, 0, 1, 2, 4, 1, 6. So occupied. So now we want to bring the page number 4. So which page to be replaced in this one? So in this one, which optimal means this is that will not be used for the long distance. The page replace for longest period. Replace the page that will not be used for longest period of the time. So in this one, 6 is a longest period means just now it has come recently. So we don't go use for this longest period. Just now we used it. So that's what we call longest period. We cannot use in future. So since only just 6 has come, so we don't use it for 6 again for longest period. So that is the meaning of this one. If you calculate this misses and hits and the fault rate, so total misses are 6 and the total events, that is total required pages are 12. 6 by 12, that is zero point 0.5. This is the minimum fault rate. This is called minimum fault rate. So if you compare this first in first out, fault rate is 0.75, and first in optimal page replacement algorithm fault rate is 0.50. So we go for another replacement algorithm also, that is least recently used algorithm. Which page not been used for the longest time in memory is the one which will be selected for replacement. So as we see in the example, the requirement with the page requirement is the sequence is given, the strings reference 0 2 1 6 4 0 1 1 0 3 1 2 1. This is a requirement, and if you there's a only 4 place frames available, space available in the RAM. So if you arrange this one, the next page is 4 to be brought here. So as for this, the page not been used for long time in memory is the one which will be selected for replacement. So in this one, 0 has come. So since long time this is not used. So that's a indication. So if you now I want to bring the fourth page from the hard disk to RAM. So now I replace 0 with 4. So this is a condition or constraint by using this page replacement algorithms least recently used. So the condition space which has not been used for longest time in memory is in 1, is 1 which will be selected for replacement. So we will replace this page as per the condition, and you will find this one. These are the missing faults, phase faults. So if you calculate the phase fault rate, that is total misses are 8 by total. This is 12 and this is 8. So 8 by 12.65. This is the fault rate. So if you compare these fault rates of all these methods, that is first algorithm, the first in first out, that for that one it is 0.75. For the second one, that is 0.50, and this is a least recently used algorithm. For this one, it is coming 0.67. So the optimal replacement algorithm is the best one because it is having the lowest fault rate. So we'll decide like this. So page replacement algorithms, still there are some algorithms available, that is page buffering algorithm. To get a process start quickly, keep a pool of free frames, one page fault, select a page to be replaced, write the new page in the frame of free pool, mark the page table and restart the process. So for everything there will be page replacement algorithm is there, that will be maintained. So next one is least frequently used algorithm. The page with the smallest count is the one which will be selected for replacement. So as you see in the running coming programs, and the more pages required, number of times it will be utilized in the program execution. That is least frequently used algorithm. The page with the smallest count is the one which will be selected for replacement. Most frequently used algorithm. This algorithm is based on the argument that a page with the small count was probably just brought in as to be replaced. So like this, there are some replacement algorithms are there. So on this one, the main memory of the operating system is divided into various frames. The process is stored in these frames, and once the process is saved as a frame, the CPU may run it. That's what we are discussing, because for execution of the program, that will be brought into the RAM. So as a result, the operating system must set aside enough frames for each process. As a result, the operating system uses various algorithms in order to assign the frame. There are mainly 5 ways for of frame allocation algorithms in the OS. These are the equal frame allocation, proportional frame allocation, priority frame allocation, global replacement allocation, local replacement allocations. So allocation of frames, equal frame allocation. In equal frame allocation, the processes are assigned equally among the processes in the OS. For example, if the frame has 30 frames and 7 processes, each process will get 4 frames. The 2 frames that are not assigned to any system process may be used as free frame buffer full in the system. So what are the disadvantages in this one? In this system, which process of varying sizes assigning equal frames to each process makes little sense. Many allotted empty frames will be wasted if the frames are assigned to a small task. That is the interpragmentation. So allocation of frames, proportional frame allocation. The proportional frame allocation technique assigns frames based on the size needed for the execution and the total number of frames in memory. So the allocated frames for process pi of size SIR A is equal to SA by S into M, in which S represents the total of the process sizes and M represents the number of frames in the system. So what are the disadvantages in this system? The only drawback of the algorithm is that it doesn't allocate frames based on priority. Priority frame allocation solves this problem. So we'll see that's a priority frame allocation. Priority frame allocation assigns frames based on the number of frames allocation and processes. Suppose a process has a high priority and requires more frames then frame will be allocated to it. Following that, less priority processes are allocated. This is a frame allocation as per the priority of the process or job. So you see what is global replacement allocation. Global replacement allocation, when a process requires a page that's not currently in the main memory, it may put it in a select a frame from the all frame sets, even if the process is already utilizing the frame. In other words, one process may take a frame from another. So this is called global. The term is that is global allocation. The process, what the advantage of the global replacement allocation is, the process performance is not hampered, resulting in higher system throughput. The disadvantage is the process itself may not solely control the phase fault ratio of the process. The paging behavior of the one processes also influence the number of pages in the memory for a process. So local replacement allocation. When a process requires a page that's not already in memory, it can bring it and assign it to a frame from its set of allocated frames. So that is called local allocation, replacement allocation. So advantages, the paging behavior of a specific process has an effect on the pages in the memory and page fault ratio. So disadvantage is, so it allow priority process may abstract high priority process by using this share. Thrashing is one of the main concept in this operating system. So thrashing is when the page fault and the swapping happens very frequently at a higher rate, and then the operating system has to spend more time in swapping out the pages. This state in the operating system is known as the thrashing, because thrashing, the CPU utilization is going to be reduced or negligible. If you look at this diagram, this is CPU utilization and this is the degree of multiprogramming. So this is called thrashing, means your swapping out the pages are taking place at one particular place, it is a maximum peak. So swapping in, swapping out is maximum. So in that case, at this particular point, the efficiency and the multi-program CPU utilization will coming down with increasing of the multi-programming. So this is called thrashing. So at this point, our CPU utilization start decreasing. So because of this more multi-programming. So that is called thrashing in, thrashing out. So because of this reason, CPU utilization will go down, our system performance will come down. So this is called thrashing. So thank you. Tomorrow we will discuss another topic.
Like, share and subscribe. Hit the bell icon for more updates.